From the dawn of humanity, we have gazed up at the stars with wonder and curiosity. Today, that ancient yearning to venture beyond our terrestrial cradle has evolved into a tangible ambition to colonize other planets and secure the future of our species among the stars. Our journey begins with understanding our place in the universe. With advancements in astronomy and space exploration, we are discovering more and more exoplanets, planets that orbit stars beyond our solar system, some of which may hold the key to life as we know it. The quest to find another Earth is one of the most exciting and challenging endeavors in modern science. Astronomers are constantly scanning the heavens, using increasingly sophisticated telescopes and techniques to detect and characterize exoplanets. One of the most successful methods for detecting exoplanets is the transit method, which relies on observing the slight dimming of a star's light as a planet passes in front of it. By analyzing the frequency and duration of these transits, astronomers can determine the size and orbital period of the planet. Another method, the radial velocity method, measures the wobble of a star caused by the gravitational pull of an orbiting planet. These and other techniques have led to the discovery of thousands of exoplanets, ranging in size from gas giants larger than Jupiter to rocky worlds comparable in size to Earth. While most of these exoplanets are too hot or too cold to support life as we know it, a small but growing number are located within the habitable zone of their stars, the region where temperatures are just right for liquid water to exist on the surface. The discovery of these potentially habitable exoplanets has fueled our imagination and intensified the search for extraterrestrial life. Among the thousands of exoplanets discovered so far, one stands out as a particularly promising candidate for harboring life. Kepler 186f. Located about 500 light-years from Earth in the constellation Cygnus, Kepler 186f is the first Earth-sized planet discovered within the habitable zone of another star. Kepler 186f orbits a red dwarf star, Kepler 186, which is smaller and cooler than our Sun. Despite orbiting so close to its star, Kepler 186f receives only about 1/3 of the energy that Earth receives from the Sun, placing it towards the outer edge of the habitable zone. While we don't yet know the exact conditions on Kepler 186f, its size and location suggest that it could be a rocky planet with liquid water on its surface, two key ingredients for life as we know it. The discovery of Kepler 186f represents a major milestone in the search for another Earth, demonstrating that planets like ours do exist in other solar systems. Future telescopes, such as the James Webb Space Telescope, will be able to study the atmospheres of these planets, searching for telltale signs of biological activity. The discovery of life beyond Earth, even in its simplest forms, would be one of the most profound discoveries in human history, fundamentally altering our understanding of our place in the cosmos. While the discovery of potentially habitable exoplanets like Kepler 186f is incredibly exciting, the prospect of actually reaching these distant worlds presents a formidable challenge. The vast distances between stars pose a significant obstacle to interstellar travel, requiring us to develop entirely new forms of propulsion and overcome numerous technological hurdles. Even the closest star system to our own, Alpha Centauri, is over 4 light-years away, meaning that it would take light traveling at a speed of approximately 186,000 miles per second over 4 years to make the journey. The Voyager 1 spacecraft, the farthest human-made object from Earth, traveling at a speed of about 38,000 miles per hour, would take tens of thousands of years to reach Alpha Centauri. Clearly, conventional chemical rockets, which rely on the combustion of fuel to generate thrust, are insufficient for interstellar travel. To overcome this limitation, scientists are exploring a range of advanced propulsion concepts including fusion propulsion, antimatter propulsion, and warp drives. Fusion propulsion, for example, would harness the energy released by fusing atomic nuclei, the same process that powers the Sun. Given the immense challenges of interstellar travel, one proposed solution involves the concept of generation ships. These massive, self-sustaining spacecraft would carry hundreds or even thousands of people on multi-generational voyages to distant stars. Generation ships would need to be entirely self-sufficient, capable of producing their own food, water and oxygen, as well as recycling waste and providing for the physical and psychological well-being of their inhabitants. They would essentially function as miniature, closed-loop ecosystems, replicating the conditions necessary for human life over extremely long periods. The challenges of designing and building a generation ship are immense. Aside from the technical hurdles of creating a self-sustaining environment, there are significant social and ethical considerations. The original crew would be committing themselves and their descendants to a life confined within the ship, with no guarantee of success or even survival. Upon reaching a potentially habitable exoplanet, another significant challenge awaits, transforming it into a world suitable for human life. This process, known as terraforming, involves deliberately modifying a planet's atmosphere, temperature and surface to make it more Earth-like. One proposed method involves introducing specific microorganisms to the planet's atmosphere, which would gradually convert its composition to one more suitable for human respiration. For example, genetically engineered cyanobacteria could be used to convert carbon dioxide in the atmosphere into oxygen, mimicking the process that occurred on early Earth. Another aspect of terraforming involves regulating the planet's temperature. If the planet is too cold, giant orbital mirrors could be used to reflect more sunlight onto its surface, warming it up. Terraforming a planet is not a quick fix. It would likely take centuries or even millennia to complete. As we venture further into space and contemplate the possibility of colonizing other planets, it is crucial to consider the ethical implications of our actions. One key ethical concern is the potential impact of human colonization on any existing life forms on other planets. Just as we would not want extraterrestrial visitors to harm or displace life on Earth, we have a moral obligation to avoid causing harm to any life that might exist elsewhere in the universe. This requires careful exploration and assessment of potential landing sites and the development of protocols to minimize the risk of contamination. The pursuit of space exploration and the possibility of colonizing other planets represent a profound turning point in human history. It is a testament to our innate curiosity, our thirst for knowledge, and our unyielding desire to push the boundaries of what is possible. As we stand on the cusp of this new era of cosmic exploration, we are filled with a sense of both excitement and trepidation. The challenges ahead are immense, requiring us to overcome technological hurdles, solve complex ethical dilemmas, and summon the collective will and resources of humanity. Yet, the potential rewards are equally great. The colonization of space offers us a chance to secure the future of our species, to unlock the secrets of the universe, and to usher in a new era of peace and prosperity for all humankind. This is not merely a dream, but a real possibility within our reach, a future that we can create through our ingenuity, our determination, and our unwavering belief in the power of human potential. As we look to the future, we see a path illuminated by the stars, a path that leads us beyond the confines of our home planet and into the vast expanse of the cosmos. The colonization of space is no longer a question of if, but when. It is our destiny as a species to reach for the stars, to explore the universe, and to secure our place among the celestial tapestry. The journey ahead will be long and arduous, filled with challenges and setbacks. But it is a journey that we must undertake, for it is in our nature to explore, to discover, and to push the boundaries of what is possible. The cosmos beckons us with the promise of new knowledge, new worlds, and a future filled with endless possibilities. The future of humanity lies among the stars. Let us seize this opportunity with both hands and create a future worthy of our dreams. A future where humanity takes its rightful place as a citizen of the cosmos.